right? Yes or no?
Let me check again.
Multiple regression is about the formula x equal to y equals to the dv equals to many IVs. Have we done this?
Yes, I think we did.
Okay, then let's move on. To the next one, which is your t-test. Okay, the 3 t-tests, yeah, don't get confused. We'll go through it one by one. 1 sample, 2 sample, pair sample. 1 sample means only one group. There is no group AB. No group AB, yeah? We have only one group. One group of sample, and therefore it looks something like this. The data set, try to open the data set. We have only one big group and the measurement of the screen size, for example, because we want to compare this screen size with a standard measurement, 10 cm. We want to find out whether the screen size of this sample, this one group of sample, is different from the standard. So when you perform the one sample t-test, you will need to key in the standard measurement that you want to compare it with. Where does it come from? The lecture notes. I've already shared others now. I still got lecture notes link. Lecture notes. Link to the lecture notes. Classroom has expired. Reset already, ma. So result, okay, let's take a look at the result. You will be checking the SIG again. If the SIG is smaller than 0.05, 0.05 is insignificant. Insignificant, yeah? Right? Greater than 0.05 and therefore not significant. This is, this one must be smaller than 0.05. So since it is larger than that, then it's not significant. If it is not significant, SIG not significant, which one shall we accept? If it is not significant, which one shall we accept? Null or alternate hypothesis? If the SIG is larger than 0.05, means it's not significant.
No
Then
hypothesis, right?
yes, we should accept null hypothesis, reject your alternate hypothesis. Okay, let's move on to, that is one sample t-test, only one group of sample that we are testing. You're not comparing it with other sample. You are comparing it with a standard measurement. Next is 2 sample t-test, means you have 2 groups of students, 2 groups of athletes. For example, group X, group Y. Group X is given placebo, means a drink that tastes like coffee. And then group Y is given the real caffeine drinks. Then after that, you are going to record the effects of caffeine in their sports performance. Hypothesis. Alternate hypothesis is that sport performance will be increased by taking caffeine. So you're comparing 2 groups, those who take caffeine and those who don't take caffeine, 2 groups, 2 samples. Okay, then you will be able to see the result like this. If you want to take a look at the sample of your data, it is is something like this. We have group, experiment group 1 and 2. So 2 groups here. 2 groups. And the result will tell us that SIG is larger than 0.05 again. And therefore, we accept null hypothesis. Not significant. Larger than 0.05 means not significant. Okay, let's move on. Paired sample t-test means one group also. One group also. But that same group of people is going to take the treatment before and after. For example, same group of car, you're going to change the tire with different rubber material. So before you changing it, you test their performance, tire performance. And after you change it to another material, you test again the performance of the tire before and after. But this tire belongs to the same group of car. Same. Bye. Belongs to the same group of car. Same one group only. Bye. Love you. Same group of car, same batch of car. There is no two groups with different rubber material. No, same one group, but they are taking before and after performance. In this case, you use pair sample t-test. After you run it, then SIG smaller than 0.05 means it's significant. If it is significant, which one should we accept? Which one shall we accept? Which one shall we accept?
Null hypothesis.
You tempat. SIG is smaller than 0.05.
Oh, this one an alternative.
Then accept alternate hypothesis. Okay, any question regarding one sample, only one group? Two sample means comparing two groups. And paired sample, comparing yourself with different treatment, before and after certain treatment. If you have no question, please try this one. The following analysis method is correct. Let me share only that screen so I can see your answer. Okay. Then take 5 minutes time. Then each group, group 1, write down your answer. Group 2, write down your answer. Group 3, write down your answer. How many groups we have? Group 6. Wow, we have 6 groups. Okay, then group 4, write down your answer. Group 5 and group 6. Oh, you are not with your team member, right? Well, then you have to open another Google Meet to discuss the answer. Take 5 minutes to do this. Okay, what is your answer? Which one is correct? Can you type at the chat box here? Okay. Let's check the answer. There is a difference of research method scores of the student before and after attending a training. So you have before and after. It's a PET sympathy test, correct? So one is correct. The score is positively related to attending to training attended. We do not compare. So this one is incorrect. But what can we use for this to test this? Positively related. Which data analysis method we can use to test this? One sample did not tell us positively related or negatively related, right? Well, you use this analysis in your assignment, positively related or negatively related. Yeah, Pearson correlation. Thank you very much, Jung Han. Okay, let's move on. RM score of RSD student differ from last semester average 75. So we have a standard 75%, one sample details. Correct? This is correct. 4. Students who attended training will perform better research score as compared to those who are not attending this training. So 2 groups here. We make comparison, 2 sample tests. And the third one is actually, the last one is actually the same as the fourth one. So this, if your fourth is correct, then fifth is incorrect. It should be 2 sample because you are comparing 2 different groups. All right, good. Let's move on. To the next one, which is ANOVA, and this is the last slide. Okay, ANOVA, we are going to cover one-way and two-way ANOVA. One-way ANOVA means you have one IV, one DV in your hypothesis, but your IV consists of more than 2 groups. Just now in your t-test, we have 2 sample t-tests, 2 groups, right? 2 sample t-tests, 2 groups. We're comparing 2 groups, 2 sample t-tests. But what if you have 3 groups, 4 groups, 5 groups? So for more than 2 levels in the more than 2 level in your IV, but only one IV, just that in that one IV, you have 3 different groups. For example, the smoking. Look at the smoking. Okay, you have 0, 1, and 2. 3 groups. 0, 1, and 2. 3 levels of smoking habit. Therefore, one-way ANOVA is an extension of the test. One-way ANOVA is an extension of the test. The test only tests 2. One group, 2 groups. Then one-way ANOVA, 3 groups and above. Okay. Then you will be able to see the result, which is like this one. If you implement the one-way ANOVA, result is this slide. Okay, F and SIG. So F has to be larger than 1. SIG smaller than 0.05. Then only you can accept your alternate hypothesis. Okay, F must larger than 1, SIG smaller than 0.05. Then only it is significant. The difference between two groups are significant. That's one way. Okay, now two-way ANOVA. Two-way ANOVA means you have one DV, but many IVs. In this case, gender and groups, different group type are 2 IVs. 2 IVs, but 1 DV. 2 IVs, 1 DV. And the result will show this. Your individual IV will significantly affect the treatment or the result of the treatment. Result of the treatment, maybe it is the test score, your midterm test. Gender will affect midterm test score. Group will affect midterm test score. Right? But then gender times group will not affect. If you put 2 together, it will not affect. Will not significantly affect. There is no significant difference between them. That's for two-way ANOVA. 2 IVs when you put together. Let me give you an example. Perhaps you get confused. All right. Let's see. With a fresh start here, so don't get affected. All right. Now, let's say we have gender. Gender, we have male and female, right? Male, female. F, this is M. Okay, let me give you an example. If let's say I have a consultation hour and there is a male and female student come and see me at the same time. Okay, at the same time, one lady, one man. When they approach me without knowing where they are from, which group they are from, immediately in my mindset is that, well, I will entertain the male first because